All right, so we're given an f of x, that is this square root function, and a g of x, and we're asked for the derivative of f of g of x at x equals 3. There are two ways to do this. Option 1 is the option I probably would have picked, but it's definitely not the only option. So I probably would have found f of g of x and said, hey, that thing that I'm just going to call y is the square root of, I plug in g into the f function. So it's going to be the square root of this g function squared minus 4. So that means my y prime, meaning the derivative of f of g of x, is going to be 1 over 2 root stuff, which is this ugly, distracting, crazy mess, times the derivative of the stuff, which is going to be 3x minus 2 quantity to the first times the derivative of the 3x minus 2. And then I'm just going to find y prime of 3. I think that's the easiest way to do this, so I'm going to get 2 times a 9 minus 2 times a 3, which we'll deal with in a sec. On the bottom, I get a 2 times the square root of, again, this is a 9 minus 2 squared minus a 4. So I'm pretty sure I get a 2 times a 7 times a 3 on the top. And on the bottom, I get a 2 times a root 49 minus 4. So if we clean this up a little bit more, this is a 2. I'm going to leave it as a 2 times a 7 times a 3, and I'll show you why in a sec. On the bottom, I have a 2, and then this is definitely a 45, which is a 9 times 5. So that's relevant because I can make this a 3 times a root 5. So I get a 2 times a 7 times a 3 on the top, and at the bottom, I have a 2 times a 3 times a root 5. These guys cancel, and I get a 7 over root 5, which is answer A. And that's great. Okay. The other way to do this, and I just wanted to throw that out there as an option in case you were curious, right? And it's not necessarily how I would have done it, but you certainly can. You could leave things in sort of a more abstract way. You could say, hey, y prime is the derivative of the outside, with the inside the same, times the derivative of the inside. And then you could separately find those things, right? So g of x is 3x minus 2, which means g prime of x is a 3. Right? So you can literally replace this thing with a 3 all the time, right? F of x is this thing. So f prime of x is 2 root the thing on the bottom and then the derivative of the inside of the root on the top. So you could cancel the 2's and just get an x over that square root. The reason I mention all that is then if you wanted to find y prime of 3, you could say, oh, that's f prime of g of 3 times the thing we already know for sure is a 3, because g prime is always a 3. Well, g of 3 is 9 minus 2, which is 7. So you want f prime of 7 times a 3. Well, we now know what f prime is, right? So that's going to be a 7 over root 49 minus 4 all times a 3. Well, that's a 7 over a, we established already that this is a 45, so that's going to be 3 root 5 all times a 3, and then you still get 7 over root 5. Again, just a different way to get to the same answer. Doesn't matter to me which one you pick. I was just pointing out you have some options.